Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will discuss the different types of yarns used for protective textiles. So, any protective textiles, for that we need different types of yarn. So, here we will try to briefly discuss the different types of yarns which are used for human protection. So, the yarn structures for protective applications. So, obviously that ring spun yarn is used in widely in protective textiles, provides high strength and uniformity because it due to its uniformity and due to its helical structure, perfectly helical structure, it provides the strength as compared to other staple fiber yarn. So, ring spun yarn is basically this is the staple fiber to yarn formation. Compact spinning is actually it is one variant of ring spun yarn where we add one component at the ring frame to reduce the hairiness. So, another one additional component is being retrofitted or maybe modified. Ring frame, the drafting zone is normally modified and to produce the compact spinning with reduced hairiness, and as the hairiness is reduced, and so it gives much better characteristics that we will discuss, and enhanced abrasion resistance. And composite yarns are there, like where if you in staple yarn normally strength is lower than filament yarn. So, in composite yarn we can actually use filament, we can introduce filament along with the maybe staple and another filament yarn to enhance the characteristics. Like if we want to increase the strength, so we can use a filament yarn in the core and in the sheath maybe cotton to improve the cotton is used for comfort characteristics, and in the core the filament is used for the strength, or sometime metallic filament we can have, or conductive filament we can use to enhance the conductivity. So, different characteristics we can achieve, or we can create the wrapped filament. Okay. So, this is suppose here it is a core filament, and the at the sheath staple yarn or filament yarn can be wrapped. So, this will form a composite yarn. Coat sheath type yarn is also possible. So, where the high strength fibers are used at the core, and sheath we can use different fiber to create different types of application, yarns for different types of application, like cut resistant yarn. Coat spun yarn provides layered protection for a specific hazard like chemical or electricity. So, different types of yarn we can produce. Also filament yarn which produces the provide high strength chemical and resistance. So, one is the staple yarn, staple yarn can be produced in different process, and also you can use the filament yarn. Twisted yarn, 2 or more strands can be twisted together to enhance the strength and durability. So, different types of yarns are used for protective textiles. Now, first let us see the very briefly what is ring spun yarn. So, this is the ring spun yarn structure, where we can see the proper the helix structure. One can very well see the fibers are twisted together to form the yarn, and here in ring spun yarn normally we will see that the hairs are formed little bit, and there are at different stages. It has in the ring spun yarn is manufactured with the different processes like blow room, carding, draw frame, roving frame, ring frame. So, at different processes, ring spun yarn is a type of yarn made from continuously made by continuously twisting and thinning a roving fiber. That means thinning means by stretching. So, if you have a roving, so with the help of the drafting roller, so it gets stretched and to form the ring spun yarn. So, fibers are highly aligned and tightly twisted. So, they are aligned and tightly twisted. So, you will see the most of the fibers are aligned together, provide better strength and uniformity. Now, this is the ring spinning process, where the roving is fed at the back, okay, and there here you will see that roving is there, and from roving it goes to the drafting rollers. These are the drafting roller, aprons are there, drafting, it is getting stretched. So, depending on the fineness required in the yarn, it gets stretched, and from there it is actually going to the twisting zone. This is the actually spinning zone, where twisting and winding takes place. So, this is the bobbin, and this is the and it is a fitted on a spindle. Spindle is driven by a belt here, and the ring is stationary, where traveler is there, which moves with the help of the drag of yarn, pull of yarn. So, and the bobbin rail, the ring rail moves up and down. So, to form the to traverse. So, for winding we need the traverse. This is the yarn path, and C shaped traveler is there, a ring rail. Okay. So, this is the process of ring spinning. So, roving is drafted here to reduce the thickness and of aligned fiber. Here it is a drafted. Ring frame system imparts twist, increase cohesion. So, twisting is imparted at in this zone with the help of the traveler and this ring. So, due to the rotation of the spindle, the bobbin also rotates and the yarn is actually the traveler is pulled by the yarn along the track of the traveler. Traveler is pulled by the yarn pull and it moves along the ring. This twist can be of two direction, S direction or Z direction. Now, this is the yarn. So, here in this may be in this direction, or if the spindle rotates in other direction, that may be the format. Now, here what is S and what is Z direction, you can see if the fiber alignment forms a Z type of shape, this is Z twist, and if it forms the S type of alignment, this is the S twist. Now, I will show you earlier. So, this is here the fibers are aligned in this direction, that means it is a Z twisted. So, this is Z twisted, Z formation is there. So, that is how the twist is classified. The yarn is continuously twisted and wound on a bobbin. So, here the winding and twisting takes place together. So, that we are not going in detail, because you can see, you can read and you know this thing, because this due to the winding and twisting clubbing together. So, that is a limitation, we cannot go for very high speed in ring spinning. So, characteristics if you see here, high tensile strength due to tightly twisted and aligned fibers. Fibers are aligned and parallel to each other, smooth and even surface with fewer imperfection we can create here, soft hand feel and comfortable for apparel. So, because here we can control the twist level, we can create and yarns are fibers are aligned. So, that is why it is a soft hand feeling. It is resistant to abrasion and wear. It is lustrous and suitable for dyeing and printing. It can be made from wide range of fiber. That is a beauty of ring spun yarn. So, we can use wide range of fiber, maybe synthetic, maybe cotton, wool or different type of fibers we can use. Even metallic fiber like stainless steel can be blended with viscose or polyester to form a ring spun yarn. And as I have mentioned, due to the clubbing of twisting and winding, and due to the limitation of the traveler speed, and slower production speed is there compared to open end rotor spinning or any other spinning. Another disadvantage is there here, we have to go for the roving manufacturing. So, other modern spinning we directly get the yarn from the sliver, bypassing the expensive and complex roving process, because roving process is actually it adds to the cost. So, ring spun yarn is smoother and softer compared to regular cotton yarn, okay, due to the tight continuous twisted form, okay, tight twisted process creates strong compact yarn and more durable. And due to the porous structure, the ring spun yarn retains the breathability, improves air circulation and moisture absorption for comfort. Tightly bound, longer fibers reduce the fuzzy and peeling. So, if we use the short fiber, then it may create the fuzzy fibers. If we use the long fiber, these fibers will be aligned towards the in the yarn structure. It will be within the yarn structure. Unique structural design improves the abrasion and tear resistance. That is important. Fine dense yarn absorbs dye evenly, producing richer, more vibrant color. So, it can be used for various applications, and different fibers can be used. We can produce wide range of yarn fineness, yarn count, and for that we can use very fine, we can produce very fine yarn to very coarse yarn. So, diverse applications we can use for in the ring spun yarn. Like in rotor spinning, we cannot produce fine yarn, very fine yarn. So, there is a limitation, or similarly for air jet spinning, we cannot produce very coarse yarn. So, but ring spinning yarn, ring spun yarn, in ring spinning we can produce wide variety of yarn counts. So, the limitations mainly in the speed is the limitation. So, lower it is a very slower, it is a slower than open end or rotor spinning. So, that is a major limitations. That is why the it is a expensive process, more energy due to traveler and ring friction. So, ring spinning use more energy, that is why production cost is high, and also in ring spinning we, as I mentioned, that we use additional process of roving frame. So, that also adds to its cost. So, ring spin yarn is costlier than the rotor spun yarn. Ring spinning involves more steps, including roving stage, and that is absent in other methods, adding complexity and time. Productivity is reduced. Yarn breakage occurs more often because of frictional force between yarn, ring and traveler. So, in case of ring spinning, so the stoppage of breakage will be there more due to high frictional force, and which adds the defect in the yarn. One breakage will add one defect. Maybe for modern splicing system it is there, but there will be anyway defect will be there, and it will affect the productivity. High speed operation on the traveler can cause damage of fiber. So, that is important. It can because it traveler, it goes through traveler and ring. So, it sometimes it creates the fiber damage. So, fiber dust sometimes it generates. Another thing is that here when we produce, produce yarn in a ring spinning, we produce yarn in a small cope form. So, I will show you. You can see this is a smaller cope, where hardly quantity will be maybe 50 gram or maybe 100 gram maximum. that type of yarn we will be producing. So, this yarn corp. So, for that we need another process. So, another process smaller than those from other spinning method. So, we to form a larger package we need again we have to rewind it, we have to form a cone winding machine is used, but in other form of spinning we directly get bigger cone package. So, it is actually that is why it is a little bit costly, but in spite of all these things ring spinning has got its own advantage. You can control its flexibility, control the its pore size. So, that is why for apparel application ring spinning is still it is very useful. Complexity of the ring spinning machine requires skilled operation, this operator and regular maintenance. So, for in case of end breakage we can have we need skilled operator. So, due to lower productivity, high energy consumption and higher maintenance requirement, ring spun yarn production trend is to be it tends to be costlier. So, for very specialized application we have to use the for protective garment we should use the this ring spun yarn, otherwise we can go for filament or maybe other mode of spinning. The applications typically in apparel application we use apparel t-shirt, shirts, dress, jeans we use ring spin yarn where the flexibility and comfort are important. In home textiles, bed sheets, pillowcases, towels, upholstery fabrics we use ring spinning and protective on workwear, uniform and industrial wear. So, there where we have to add comfort along with the protective workwear, there the ring spun yarn is useful. High end textile like luxury fabrics, fine knitwear, fashion textiles, there we use the ring spun yarn. And in case of blended fabrics, often blended with synthetic fibers. So, for when we use the blended fabric, so as a ring frame we can use different types of fiber easily. So, for blending blended yarn we can use ring spun yarn. Next is the compact yarn. Compact yarn as I told it is an additional attachment. Now, this is the compact spinning yarn where you can see the hairiness content is much less than almost it is absent hairiness. So, there that is why compact spinning is used here. Now, the difference between normal ring spinning and compact spinning is basically the spinning triangle width. So, this is the say front roller of ring spinning. So, if we see the normal ring spinning, this is the normal ring spinning. Here the drafted fibers are coming from the back say middle roller, and after that these fibers are converged to form yarn. This is the twisted portion and this is the spinning triangle. Here the problem here is that when the fiber gets sudden deflection, the fibers will tend to come out from the at least edge fibers will tend to come out from the this path edge fibers and they will form the hairs. Okay. This fibers will not take part in the yarn strength consideration, but in case of compact spinning, these are the fibers which are coming from the middle roller or it is from the apron. After that, from the middle after that during the here there will be some modification, and in this zone the compacting zone will be there, maybe in aerodynamic process like by the compressed air or maybe mechanically, this the width of this fiber fringe, drafted fiber fringe is reduced before it is coming at the nape of the frondular. This is the frondular nape. So, here it will be very narrow, and when it is coming it will come like this and from the just from the. So, there is a least chance of fibers coming out from the structure of the yarn. So, fibers, that is why you will find here in this picture the hairiness are absent and all the fibers are coming within the yarn structure and taking part in the yarn strength. So, compact spun yarn is a type of ring spun yarn produced using a compacting process. Here ring spun yarn, here compacting process is added, fibers are tightly packed and aligned as I have mentioned here. That is it reduces the width of the fiber strand. So, that is the actually main function of the compacting system. It reduces the width of the fiber strand before it reaches the frondular nape. This is the frondular nape. Frondular nape. Significantly minimizes or virtually eliminate the spinning triangle. This spinning triangle is there, it is virtually eliminated here. Okay. That is the compacting process, and the advantages what we are getting. See, if you see the yarn, normal yarn, this is the normal yarn where hairs are throughout the surface, and another yarn without any hair. Now, here these hairs are not taking part in the strength. So, that means equivalent compact spun yarn will be stronger than normal ring spun yarn. Second is that you can see here the light when it falls, it will get scattered with the from the hairs. This hairs will scatter the light. So, light will get scattered, but here as the hairiness is almost absent, the light will have almost regular reflection. So, that means that this yarn will be much more lustrous than compact spun yarn, will be much more lustrous than the ring spun yarn, equivalent ring spun yarn. So, it will improve the characteristics of yarn, which is used for mainly apparel textiles. It is hardly used in case of protective textiles, but one can always use. Now, you can see here, this is the frondular nape, and here some grouped, there are different systems. Here this grouped roller which is provided, which actually which reduces the width of the spinning triangle. The fibers are cleaned, blended and converted into sliver through carding, drawing and similar to ring spinning process. The sliver passes through the compacting device and reduces the fiber width and align more. This is here basically the drafted, not the sliver, drafted web. Okay, drafted web is actually aligned. The compacted fibers are then twisted to a ring spinning. The finished compact yarn is wound onto cone package for. So, this is the normal process, but here main compacting process is here. Now, the characteristics I have already mentioned that fewer protruding fibers giving smoother surface, surface will be very smooth. Tightly packed fibers increase tensile strength, because in normal ring spinning the fibers are forming the hairs, those are not so tightly packed. Consistent diameter, twist reducing irregularity, because the fibers are all aligned towards the yarn, because it is brought back to the yarn structure. Smooth and comfortable, suitable for apparel. It is resistant to peeling and abrasion, because the hair any peeling starts from the protruding fibers. So, due to the rubbing action, the protruding fibers gets rolled and forms micropeel, and gradually this micropeel is the sizes increase, and that forms the visible peel. Lustrous and neat, ideal for high quality fabric. So, as I have already discussed, due to the regular reflection it becomes lustrous and neat, because the absence of hairs the structure becomes neat. So, it absorbs dye evenly for vibrant color. So, the advantages are it is improved strength compared to a regular ring spun yarn, fewer protruding fiber giving smooth surface and less peeling, produces lustrous uniform fabric with finish. Even deeper and brighter coloration, because we of the absence of hairs or peels, it enhance the abrasion resistance and fabric's longevity, because of the less hairs. Smooth hand, ideal for high quality apparel. The limitations basically it lies on the cost, because we have to have some additional attachment. Special compact spinning attachment increases production cost, that is a major limitation, and slower than rotor and open spinning, because it is attached with the ring spinning. Whatever disadvantages as far as the productivity is concerned, it is there, because same ring traveler zone it will be there here. like suction system requires frequent cleaning. So, this additional compactor system where the air suction is used, that or even for mechanical like grouped aprons are used, there frequent maintenance is required. So, that maintenance cost is high, and we have to create some inventory for the this replaceable items, more suitable for fine and medium yarn, less economic for coarser yarn. So, we use this compact yarn for mainly for shirting purpose, where fine yarns are used. Additional suction and air system consumes more energy. So, energy consumption will be more, that means cost will be very high. The applications, if we see here, high quality apparel, we use the compact spinning, shirt, t-shirt, trouser, suits and fine knitwear. So, where the expensive apparel we can use here, home furnishing for bed linen, pillow covers, upholstery fabric, we use this. Industrial textile in swing thread, where we need less hairiness. So, swing threads and technical fabrics we use, and luxury and fashion fabrics, there we use the compact yarn. Next is the composite yarn. Now, you can see the composite yarn, different types of composite yarn. Here you can see here the filament core and staple fibers are staple fibers are at the wrapped at the sheath along with the filament core to get high strength. Filament core gives the high strength mechanical characteristics, and staple fiber sheath which is wrapped, which gives maybe cotton, which gives the comfort characteristics or soft feeling. Here staple fiber core and multi-filament wrap. So, the wrap spinning we can also get, okay, fiber wrap staple and staple fiber at the core, and staple fiber yarn or staple fiber at the core and staple fiber at the sheath, that also you can produce, and say polyester multi-filament at the core and cotton at the sheath. So, different types of combinations we can make. Okay. So, there you can see here it is another multi-filament, here another multi-filament. So, three type of structure, multi structures we can use. So, composite yarn is a multi-component yarn made by combining two or more different types of fibers or filaments. So, this multi-component yarns are used for many protective applications like your cut, slash resistant textiles or fire protective textiles, different applications we can use, or typically consist of core and sheath or side by side arrangement. And designed to combine the advantages. So, advantage of sheath fiber, advantage of core fibers are there. So, we should design to use the advantages of both the fibers. Okay. The spinning process we can see here, this is the friction spinning process and very widely used for technical yarn production. Now, here you can see the feed sliver which is staple fiber. Here core either in the form of yarn, staple yarn, or maybe the sheath, maybe the filament, maybe any type of filament, continuous strand can be used, maybe metal at the core. So, any type of applications we can do, and at the sheath here we have to have staple fiber. So, maybe stainless steel or carbon at the core, carbon filament, and at the sheath maybe cotton. So, which what we will get? We will get very high strength, and at the surface we will get the softness. So, this is the these are the different ways to create this fiber, this composite yarns. Even coarse spun yarn we can make in the ring spinning also, we can produce. Selects 2 or more different fibers or filaments as far as cotton, polyester or filament, staple. So, different types of combinations we can make. A filament or strong fiber bundle is fed as the core. Okay. This is fed as a core. Staple fibers are drafted around the core, okay, through the ring spinning. So, here you can have in the ring spinning we can use the, this is say ring, I will draw it, just try to see. Let us, this is the drafting zone in a ring spinning. Okay. In the ring spinning, so fibers, the staple fiber like cotton is getting drafted. Okay. Here it is from the roving it is coming, it is getting drafted, and here there will be twisting and ring spinning, ring and traveler zone. But before that, if we want to have coarse spun yarn, so there is a spool, say maybe any polyester or any filament. Here it is fed just before the front roller nip, and then it is getting twisted. So, you can place it like that, so that we can get the coarse spun yarn. Core and sheath are twisted together to lock the fibers in place, ensuring strength and cohesion. Then they are twisted together. The finished composite yarn is wound on a cone and bobbin. So, this is the system of composite yarn production. Now, the characteristics that depends on the type of fibers is or filaments used, made from 2 or more fibers or filaments type to combine their properties. So, we can create the advantages of the positive aspects of the fibers, provide greater strength, durability, elasticity than single fiber yarn. It can be engineered to for properties like strength, abrasion resistance, moisture control, thermal regulation, aesthetics. So, different characteristics we can incorporate. Suppose we want to create a very high strength soft material. So, then we should use a very stronger filament at the core and the softer fiber like cotton at the sheath. So, that type of engineering we can do in the yarn structure, and which is used for widely for the protective textiles. Retains a softness, breathability when blended with natural fiber. It reduces shrinkage and improve the shape retention compared to 100% natural yarn. So, that is a type of yarn we can create here. Depending on the fiber mix, it can have smooth surface, less hairiness or better luster. So, different types of yarn structure or yarn characteristics we can create. Balanced performance and cost by blending expensive fiber with cheaper one. So, we can use the cheaper fiber at the sheath, at the core, and hiding that the negative characteristics, and put the expensive fiber, that is at the sheath, with the lower proportion. Like I will tell you, suppose I want to produce woolen, wool is expensive fiber. So, there what I can do, I can give the cotton at the core, cotton yarn, and wool at the sheath. So, we can get yarn with a wool filling, but cheaper, relatively cheaper fiber at the core. So, it can have any other fiber, maybe jute fiber. So, that flexibility is there. So, the advantages are, it combines the best properties of different fibers. So, we can use the positive aspects of particular fiber, stronger and longer lasting than single yarn. Even one component is affected, the other component will carry the strength, maintains softness, breathability and flexibility. It offers smooth texture, reduce hairiness and better luster. It can provide UV resistance depending on the type of fiber selected, flame retardancy, conductivity, antibacterial effect. So, all this can be achieved depending on the selection of the fiber. Less shrinkage and better shape retention. So, that we can select our core yarn or one of the components with the less shrinkage capability. The limitations are basically requires advanced machinery for production. It is a normal machinery, it is not, it will not work. So, we have to either modify the machine or we have to get the advanced machinery and processes. It is expensive than conventional single fiber yarn, because we need extra attachment or extra additional advanced yarn machine. Different fibers have poor aesthetic or adhesion or bonding. So, that we have to see. So, fiber to fiber adhesion should be there. There may be sometime the yarn may fail due to the poor adhesion, but that can be adjusted by changing the properly selecting the fiber combination. That performance may vary across the yarn due to fiber difference. Like in the core we have different fiber, and then the sheath we have different fiber. Suppose in the core we are using say polypropylene, and the sheath we are using some say like cotton. So, their performance will be entirely different. Maybe their strength performance, their maybe thermal performance, mechanical performance will be different. So, that is the limitation. We cannot get uniform performance, blending fiber with different shrinkage, dye uptake and thermal behavior can cause a defect. So, suppose here we are using say polypropylene and cotton. So, polypropylene shrinkage characteristics at that high temperature, shrinkage characteristics may be different than cotton. If it is different, then it will create some wrinkle type yarn. So, because that their extensibility or shrinkage characteristics are different. So, that will create defect, the yarn may be crimped after heat treatment. So, that we have to, because the shrinkage, if it is a core is shrinking at a higher extent than the sheath, then it will give the core will give pulling inward pulling force to the sheath and it will form the defect, wrinkle type defect. So, that is there. Hard to separate fiber type for reuse, that is the main problem of the composite, any composite product. Suppose we are using polypropylene and cotton. Now, we want to reuse this yarn, we want to extract cotton from that yarn, which is not possible. So, for composite type of yarn, so it is not we cannot use reuse is very difficult, because polypropylene in filament form, cotton in staple form. So, in reuse if we try to get, then polypropylene will be in the long, if even if it breaks, the fiber length will be longer. So, we cannot reuse this fiber for some other application. So, applications are wide: apparel, textile, sportswear, activewear, fashion garment, we use bed linen, upholstery, curtains, we use the composite yarn, technically, and rope, belt. So, ropes are used basically for by twisting, belts, geotextiles, we use this composite yarn, and protective textile, flame resist retardant, cut protective. So, we will discuss the different structures which is developed for protecting for cut protection or UV resistant workwear. So, different types of protective garments are used, medical textiles, bandage, surgical fabric, antibacterial, antimicrobial textiles. So, and automotive and transport sector, like there we seat covers, airbags, there we use composite yarn for high strength and also that soft filling. Next yarn is the coarse sheath yarn. One is composite yarn. Coarse sheath yarn is one type of composite yarn, but coarse sheath yarn here it is a type of composite yarn made from by combining two different fibers in a specific arrangement. That is the composite coarse spun yarn. The core is a central fiber which provides the strength, elasticity or other functional properties, and sheath is the outer layer fiber which offers the comfort, softness, appearance, additional functionality. So, this is little bit different from the other composite yarn. For core fibers or filaments we use for elasticity and other strength or different special properties. Spinning process. So, two or more different fibers or filaments, cotton, polyester, filament, staple. A filament or strong fiber bundle is fed as a core. The staple fibers are drafted around the core through the ring spinning, okay, and the core fiber like elastin fiber, spandex or strong filament are fed continuously through the feed roller, front roller. So, the front drafting roller, it is fed as I mentioned earlier. Staple fibers, natural or synthetic, are carded, drawn and fed around the core. The sheath fibers are wrapped around the moving core using ring spinning or friction, rotor, air jet spinning. The wrapped fibers are twisted together to form uniform yarn and wound on the bobbin. Yarn is checked for uniformity, strength, elasticity and defect. Core sheath are twisted together to lock fibers in place, ensuring strength and cohesion. The finished composite yarn is wound on a cone or a bobbin. Now, you see the characteristics of core spun yarn, core sheath yarn consist of central core wrapped by the sheath. Core provides stretch, recovery characteristics, tensile strength, and sheath softness, smoothness or aesthetic characteristics, which maintains the shape and reduce the snagging fabric. Okay. In depending on the type of fiber, natural or synthetic fiber, the characteristics of yarn changes. Like if we use high strength filament or high less elastic filament, so that will give the high strength. If we use the spandex or some stretchable elastic fiber, and that will give the stretchable yarn. An outer sheath normally protects the core. So, advantages of core sheath yarn: core provides excellent stretch and the safe retention. Sheath offers smoothness and softness, gives better feel. Core enhance the tensile strength, stretch. It can combine different types of fiber, specific function or aesthetic properties. The limitations of core sheath yarns: it requires specialized process, more expensive than regular yarn. Core sheath fibers may have different shrinkage, dyeing and thermal properties, can cause yarn unevenness, defects, not properly spun if it is not properly spun, and difficult to separate cores. So, similar to the limitations are almost similar to the composite yarn. The applications of core sheath yarns are stretchable apparel, which is used for sportswear, activewear, leggings, denim, add to stretchable denim, medical textiles, bandage, which are stretchable bandage are there, elastic support, compression garments we use, industrial textiles, ropes, cordage, we can use the core spun yarn, home textile, stretchable upholstery. So, these are the core spun yarn, and you can see the different types of core spun yarn, core sheath yarn. So, core spun yarn is a type of composite yarn, which where core is a filament and the at the sheath is the staple fiber, stronger and elastic filaments are used at the core, and in the sheath natural fibers are there. Spinning process, we can use different types of spinning process like friction spinning. Okay. We can use where the staple fibers are fed from the slivers are drafted, opened, and staple individual fibers are coming on the nip point of rotating drums, and core filaments or yarns are coming, and it is wrapped, the sheath fibers are wrapped around the core filament or yarn and forming the core spun yarn. Similarly, here it is a filament in the ring spinning, the filament is there, and which is coming and it is fed at the front drafting roller. This is the front drafting roller, and roving, normal roving is drafted in the 3/3 drafting system, and here the core spun yarn is formed. A continuous filament or yarn, spandex or polyester is fed. The staple fibers, cotton, wool or synthetic are carded, drawn. The sheath fibers are wrapped around the moving core using a ring, rotor or air jet spinning. The wrapped fibers are twisted to form a uniform. These wrapped fibers are twisted to form uniform yarn and wound on a bobbin. Then yarn is checked for defects and all this. The characteristics, if we see, it is almost similar to the this yarn, composite yarn, stronger filament, tensile strength due to the strong filament, good stretch or recovery due to the stretchable fiber, okay, elastane fiber, more resistant to abrasion and wear than regular spun yarn due to the presence of the core filament. Staple fiber sheath provides softness, comfort and natural feel, looks similar to ring spun yarn since their core is hidden into the sheath. So, it looks like a ring spun yarn, feels like ring spun yarn, but very strong. Properties can be tailored by choosing the different core and sheath. We can change the property depending on our requirement, better peeling resistance, shape retention and dimensional stability. And depending on the sheath fiber, cotton sheath improves the absorbency, that feel depends on the sheath fiber, and strength and stretchable characteristics depend on the core fiber. So, advantages are it is combining the strength of core and with the comfort of sheath. Strength of core and comfort of sheath provides high durability and abrasion resistance, offers better elasticity and stress recovery, especially for elastane like spandex core. It improves dimensional stability and shape retention, enhance swing performance, reduce breakage. So, in core spun sewing threads are used for very high speed sewing machine, where the core filament will retain its strength and sheath will retain get the very it is a good addition with the textile fiber. So, that as seen that it is due to it creates the high friction zone. So, it does not this swing thread does not come out easily. If we use only filament, swing thread will come out easily, gives natural appearance, fill due to the stretch recovery. So, limitations of core spun yarn, higher production cost, because we have to add some additional attachments, complex manufacturing process requires precise control. So, it is not that simple. So, the manufacturing process is complex, core exposure risk if coverage is uneven or worn out. So, core may come out. So, if the addition is not proper, so sheath slippage may be there. Limited fiber combinations, not all fibers are compatible for core or sheath. So, dyeing issue may occur as the sheath or core may respond differently in the dyeing. Low softness than pure yarn depending on the sheath coverage. Special machinery or modification are often required for spinning. So, applications: denim, sportswear, activewear, hosiery, socks, workwear, uniform, swing threads, casual wear. So, cord spinning is used for protective textile widely, elastic textile, technical textiles we can use protective and other applications. So, we will stop here, and the next session will start with the filament yarn and followed by different types of fabrics for protective textiles, fabric structures, and till then, thank you.